In the lesson on pressure, we saw the fundamental relationship pressure had with altitude. If you remember, we said pressure decreases with altitude. This relationship is what the altimeter will use to determine height. We've already seen how the altimeter works, but let's just recap its fundamental points. It's an aneroid barometer and therefore uses the principle that changing air pressure will cause a small chamber to expand or contract. This chamber is linked to a pointer rotating over a scale graduated in feet or meters. If we look at the diagram, we can see that a fall in outside pressure will cause the chamber to expand and turn the pointer clockwise. An increase in pressure will do the reverse. This time, the chamber is compressed, causing the pointer to move anti-clockwise. Now we've seen how it works, let's put it into practice in the atmosphere. We said pressure would decrease with height. Therefore, as an aircraft climbs through the atmosphere, the pressure will decrease and the altimeter pointer moves clockwise, showing an increase in height. Conversely, when the aircraft descends through the atmosphere, the pressure increases and the pointer moves anti-clockwise, showing a decrease in height. There's one problem. The altimeter is reading a height, and we've seen that this increases as we climb and decreases as we descend. But what is this height value measured from? If the altimeter needle is pointing at 10,000 feet, what are we 10,000 feet above? The ground? The sea? The airfield, or what? This is what the altimeter cannot tell us. What we must do is find out from which level the altimeter is assuming 0 feet. In fact, this is not an actual geographic location. It's a pressure value. The altimeter has no idea where it is in terms of objects like land and sea, but what it does know is where it is in relation to different pressure values. We can tell the altimeter what pressure to start from, but not what physical place. This is done by means of an adjustable subscale. This is a small window in the face of the altimeter, which has a pressure value either in hectopascals or inches of mercury. Whatever pressure value is set in this scale, it's the pressure at which the altimeter will assume 0 feet. Looking at the diagram, we can see that a pressure of 1000 hectopascals is set within the subscale. Therefore, if the altimeter was at this pressure level, then the needle would read 0. As we climbed, pressure would decrease from this value, and the altimeter would show how far away it was from this pressure level. Notice that the value within the subscale is not changing. It's simply reminding us what pressure value has been set as the data. Our initial problem has still not been solved. We need the altimeter to give us a height above a physical surface, not a pressure surface. We can solve this by having a variable subscale. In other words, we can manually select what pressure the altimeter will use as a 0 point. This scale is adjustable from 850 to 1050 hectopascals. Let's work through an example. If we place the altimeter on our airfield and set the subscale to the actual pressure of the airfield, then our altimeter will not only tell us how high we are above that pressure level, but also how high we are above the airfield. In other words, it will tell us our height above the ground. Getting the altimeter to read height above the airfield can be very useful to the pilots if operations require accurate height above the airfield. If we were to get the actual pressure of the airfield and correct it to the airfield reference point or threshold, then we have a pressure value known as QFE. If this pressure was set within the subscale, the altimeter would read 0 when on the ground at the threshold or airfield reference point. If the aircraft was then to climb, the altimeter would show the height above the airfield. This can only be useful within the immediate confines of the airfield. Looking at the diagram, we can see that if we were to fly 5 miles away, the altimeter will still read the height above the airfield. Notice that because the ground is uneven, we no longer have a reading that tells us how high we are above the ground in our immediate vicinity. This is not very useful and could lead to potential problems, especially if we are unable